right, we're talking about optimization again. So this example says the sum of the two non-negative numbers is 30. So I'm going to go ahead and I'm going to underline non-negative because that's an important thing. Find both the numbers if the sum of twice the first plus the square of the second is a maximum. So here's what it's telling me. I need to find a maximum. And let's start by assigning our variables. So these are two numbers, so we're just going to assign each number a variable. X is the first number, and Y is the second number. Okay, and then it says, then normally we would draw a picture here, but we don't need to draw a picture because it's not like a volume or surface area or anything like that. So our second step is to write a primary equation for what needs to be maximized or minimized, right? So then we go back to our problem and we look, what needs to be maximized here? And so I underline maximum so we could kind of look there, and it says find both numbers if the sum of twice the first plus the square of the second is a maximum. So our sum is going to be maximized, so our primary equation is going to be dealing with the sum, and twice the first number plus the square of the second number would look like that, 2x plus y squared, right? That's what that means. And we want to maximize s, right? We want to maximize the sum. So then our third step would be, remember usually we have to write two equations, not always. We saw one today. We didn't have to write two equations, but usually we need to write two. And so we need it to be in terms of one variable, and right now it's in terms of two. So we need to have a secondary equation. So this one was our primary. And then our secondary equation is going to be that when we add these two numbers together, that they equal 30. Okay, so when I add them together, they equal 30. And let's sub one in for the other so that we have our primary equation in terms of just one variable. I think the y looks uglier to square something, so I'm just going to sub in x. So I'm going to get x by itself, and that equals 30 minus y. So I'm going to sub in s equals 2 times 30 minus y plus y squared. So now I have my equation. Let's find our domain. And this is where that word non-negative comes into play, because what is our domain? So they have to add to 30. It can't be a negative number, but can it be 0? Yeah, non-negative means it doesn't mean positive. It means 0 or positive, right? So we find our domain right here. We find our domain from our new equation that we're going to optimize. Find the domain. And so y has to be greater than or equal to 0. It can be equal to 0, but it can't be greater than or less than 0. And then what's the biggest possible value it can be? Well, if we're adding it to another non-negative number, it can't be bigger than 30, right? It can be 30. It absolutely could be 30, and x could be 0, but it can't be bigger than 30. So now we have our domain, and what I want you to notice about this domain is it includes the endpoints. So we have everything in between 0 and 30, but most of the ones in our last unit didn't include endpoints, right? We couldn't have all the way up to a number. So this one includes the endpoints. So just we will see why that's important in a minute. All right, so our final step is that we're going to differentiate and find our max and min, or we're trying to find a minimum, right? So we differentiate our equation, and first I guess I'll rewrite it as 60 minus 2y plus y squared. That's our new equation. And then I'm going to go ahead and differentiate that. So s prime is negative 2 plus 2y. I set that equal to 0 because I can only have a max or a min at 0, or when the derivative is equal to 0 or undefined. I solve for y, and I get that y equals 1 is a critical number. Okay, so my critical number is y equals 1. So let's do our number line and see what happens at y equals 1. So at y equals, I just wrote 0 instead of 1. 1. Okay, so let's see what's happening at y equals 1. Well, if I plug in, say, before that, like 1/2, into my derivative, I would get a negative value. And then if I plug a bigger number, like 2 in, I'm going to get a positive value. So this is like what we were talking about actually today on Monday. We were talking about what happens if it's a minimum, right? We were looking, our question asks for a maximum. We want the maximum value that we can possibly get. And our critical number gave us a minimum, right? So if y equals 1 and x equals 29, then we're going to have the minimum possible value for this. So what do? Well, remember when we were talking about absolute max and absolute min, we talked about the endpoints. And in this case, we actually, like I was saying a minute ago, we actually include the endpoints in our calculations, right? Because y could be 0 or x could be 0. And so since this critical number we found is a minimum and not a maximum, we need to test the endpoints and see if they're any bigger, right? So let's figure out what our options are here, right? Okay, so if y equals 0 all the way up to y equals 30, right? That's our domain. We can have anything from 0 to 30. And so what's our point? If y equals 0, x has to equal 30. If y equals 1, x has to equal 29 because they have to add to 30. And then if y equals 30, x has to equal 0. So those are my 3 points that I can try. These are my 3 options. So let's figure out what they are. And figure out which one gives us the biggest possible output. Our sum equation is 2x plus y squared. So the first one, I shouldn't have written it there. I'm going to write, okay, 2x plus y squared. So the first one is 2 times 30 plus 0, which gives us 60. Ooh, that's ugly. 60. Okay. The second one is 2 times 29 plus 1, which gives us 59. Okay. And then the third one is 0, 2 times 0 plus 30 squared, which gives us 900. So which one is our min and which is our max? Well, we already knew that y equals 1 gives us a minimum, but in this case, our endpoint gives us a max. If we make y 30 and x 0, it satisfies all of our conditions, and we get a much larger number here. So the answer is x equals 0 and y equals 30. So in this case, just don't forget to check endpoints for absolute max and min, because just because a critical number is a max or a min doesn't mean our endpoints aren't going to give us even bigger numbers.